Hi, and welcome to our project on the predictive maintenance of polymer extruders. Now, I understand that these words might not mean a lot to you right now, but that's what I'm here for, so let me give you some context. Industries are struggling with unplanned downtime, where machines suddenly break down, which results in wasted resources. This not only means that companies lose money, they also waste materials, which poses a sustainability challenge. So our project focuses on a polymer extruder, a machine that grinds and heats up plastic pellets into a polymer melt. We're using recurrence plots, a mathematical tool that models dynamical systems to address this problem. By being able to predict when a fault will happen, we can prevent a severe breakdown, moving us closer to a circular economy.
Recurrence is when the state of a system is similar at two different time points. This can be understood with a sine wave, where the state is its position. If we compare the state of the sine wave at position t1 and at t3, we can see that they are similar. On the recurrence plot, this will show up as a dot at position t1, t3.
How can we use recurrence plots for predictive maintenance? Well, we applied it on a public dataset about bearing faults. Once we calculate a recurrence plot of a given time series, we are able to extract a set of quantifiable measures from this recurrence plot. These measures represent the system on a high level, and that's why we can feed them to a classifier, which then is able to predict whether a system is in a healthy or a faulty state.
We then implemented the results of the classifier into a graphical user interface, which can be utilized on the factory floor. It provides real-time information on the health of the machine, not only indicating if it is healthy or not healthy, but in the case of a fault being present, it can indicate the type and the severity of the fault.
The next thing to question is if the recurrence plot method brings in any benefits compared to its alternatives. The answer is yes. First of all, it's robust to noise, which means that if you introduce increasing levels of noise in the signal, the RQA measures don't change significantly. The other thing is that it performs way better compared to its alternatives when working with short, nonlinear signals. And last but not least, it can accurately distinguish between a wide range of faulty conditions.
Recurrence plots and their quantification allow for predictive maintenance of machines such as extruders. This brings us closer to the goal of a circular economy.